Blood flows through a complex network of blood vessels known as the vascular system. Blood vessels have a layer of smooth muscle surrounded by a thin single layer of endothelial cells. Endothelial cells interface between blood and underlying vascular tissue. They can respond to changes in blood pressure and blood flow that occur with each cardiac cycle. During cardiac activity, endothelial cells produce factors that can lead to changes in the vessel wall, such as vasodilation or widening of the blood vessel. Endothelial dysfunction is a state of activation of the endothelial cells that can impair blood flow and circulation, causing problems for exercise performance and sexual health. Endothelial function and blood flow are important for wound healing and aid in the delivery of oxygenated and nutrient-containing blood to the wound for its repair. Endothelial dysfunction is an early step in the development of vascular disease and decreases the suppleness of arteries, leading to increased blood pressure. Endothelial dysfunction impacts platelet aggregation and how immune cells interact with the vessel wall. It may also contribute to atherosclerosis and progression to heart attack and stroke. Factors contributing to endothelial dysfunction include oxidative stress, inflammation issues related to methylation and methylation capacity, and high plasma glucose. Aging is also associated with endothelial dysfunction. A healthy vascular endothelium produces factors important for its function. The synthesis and availability of nitric oxide is essential for many aspects of normal vascular function, including vasodilation. Nitric oxide synthesis can be supported through nutrition. The amino acid arginine, in combination with other factors, is converted to nitric oxide, and the amino acid citrulline by the enzyme endothelio nitric oxide synthase, or eNOS. Supplementing the diet with arginine can increase nitric oxide production for improved vasodilation and endothelial function. The nitric oxide synthesis pathway needs to be supported. Without sufficient support, the enzyme eNOS can become uncoupled from nitric oxide synthesis. When this uncoupling occurs, reactive oxygen species such as superoxide are produced instead of nitric oxide. This is harmful to the endothelium because nitric oxide is decreased, but also because the production of reactive oxygen species contributes to the development of oxidative stress and atherosclerosis. An important way to support nitric oxide synthesis is to ensure that there is a sufficient supply of arginine. This becomes especially important during illness or wound healing when arginine's use in the body is increased. Then, arginine becomes conditionally essential. Citrulline can be converted to arginine as long as citrulline is circulating in the bloodstream. Increased citrulline intake helps maintain arginine levels over time, enabling the production of nitric oxide. Another nutritional factor that contributes to endothelial function is cocopolyphenols. Cocopolyphenols have been strongly linked with improved endothelial function in clinical trials, and experts have recognized their benefit for endothelial function, blood flow, and cardiovascular health. Cocopolyphenols protect nitric oxide synthesis and the vascular endothelium in many ways. For example, cocopolyphenols can inhibit the enzyme arginase. Arginase increases in aging, hypertension, inflammation, and oxidative stress. Arginase activity can divert arginine away from nitric oxide synthesis. By downregulating arginase activity, cocopolyphenols can protect endothelial function. Cocopolyphenols can help to stabilize an important cofactor known as tetrahydrobiopterin, or BH4. BH4 is necessary for eNOS enzyme function, and without BH4, eNOS cannot produce nitric oxide. Cocopolyphenols help stabilize BH4 and ensure its functions as a necessary cofactor in nitric oxide synthesis. Other supportive nutrients for BH4 stabilization and eNOS expression are folate, vitamin C, and magnesium. These nutritional factors, as well as arginine and citrulline, contribute to protection and maintenance of nitric oxide synthesis and to healthy endothelial function. Measurements of endothelial function can add value to the promotion of health and prevention of disease above and beyond traditional risk markers. Measurements of vascular reactivity, or the ability of the blood vessels to vasodilate and restore blood flow after a period of occlusion, can be a useful assessment of endothelial function in the clinic. Blood-based biomarkers such as ADMA and salivary nitrite levels can provide insight into nitric oxide production. These measurements also enable tracking of a patient's progress with the nutrition and lifestyle interventions. Measuring and supporting endothelial function and nitric oxide synthesis are important for everyone. However, additional nutritional support to maintain healthy endothelial function and blood flow may be required in individuals with raised levels of plasma glucose, oxidative stress, inflammation, and issues related to methylation and methylation capacity, and individuals with clinical problems related to poor blood flow, or with existing cardiovascular disease or cardiovascular risk markers. Older adults and people with certain clinical conditions, such as wound healing, may also require additional nutritional support. A combination of cocopolyphenols, citrulline and arginine, in addition to other supportive nutrients, can protect nitric oxide synthesis and contribute to healthy endothelial function and blood flow. Healthy endothelial function leads to optimal vascular control and health with reduced hypertension, optimal gene methylation, improved wound healing, and overall support of inflammatory initiation phases, as well as improved sports and lifestyle performance.